Hello! Today we will be talking about the Slurm job scheduling system. You can use Slurm to submit your computational jobs on most HPC clusters. Here is a list of some commonly used commands. sinfo will print a summary of the current state of the nodes. sq will of course print the queue. srun can be used to synchronously execute your jobs, and sbatch can be used to asynchronously submit your jobs for later execution. Finally, scancel can of course be used to cancel either currently executing or pending jobs. On this slide, you can find a list of commonly used job options. Please feel free to refer to it at a later point. Let us now practically demonstrate the commands mentioned a minute ago. Here is a summary of the node state. Alloc means that the nodes are currently busy. Mix means that some of the nodes' cores are allocated, but others are available. Whereas idle, of course, means that all of the cores on the given node are available. Let's now take a look at sq. As you can see, this command prints the current state of the queue in a table. By default, it will print the ID of the job, the partition it's executing on, the name of the job, the user who submitted it, the job's state, the time it's been going for, the number of nodes that have been allocated for it, and the list of the nodes on which it is executing. We can see that some jobs are pending. This is reflected by the last column, which instead of showing the node list, indicates the reason why the job is stuck in the queue. Priority or resources simply means that the job is waiting for resources to become available. However, your jobs may be pending for other reasons. For example, if we scroll up, we can see a different reason code for this job or for this job. In this case, we can see that the user has simply exceeded their allocated CPU minutes. This means they need to apply for another allocation of resources. Here you can see that this user has reached the limit of concurrently allocated CPUs. This means that the jobs will simply have to wait until the previous jobs finish and free up the resources. You can find a full list of the job reason codes in the official Slurm documentation. A useful option for the sq command is the me flag. sq me prints only my jobs, which is usually what I'm interested in. As you can see, I currently have no jobs either pending or executing. Let's now move on to actually running our jobs. We'll start with an interactive session. To run an interactive session, you will need to call srun with the pty option and pass the shell as the command which you would like to execute. Here, you can see that I am launching bash and I am passing my account name and the partition which I would like to run my job on. If I now press enter, you will see that I have been granted a resource allocation and I am now running an interactive job. Effectively, I have started an SSH connection onto a computational node with the resource limit specified by the job parameters. Here, by default, I've only been granted one core. I am now free to execute some commands. For example, I can list the available modules. This mode is useful for small experiments or, for example, compiling some software. Here, I've prepared a small example for the purposes of this demonstration. Hello HPC is a simple C++ program which prints the rank and size of the current MPI communicator. If you'd like, you can pause the video and examine the code. To compile it, I will first load the MPI module. And now I'll invoke the compiler with some relevant flags. As you can see, I have produced an executable. If I execute it, you'll see that it will print the information that I am only running one rank on one node. To exit the interactive session, press Ctrl D. Let's now move on to batch mode, which is the main way that you should be submitting your computational jobs. To perform the tasks which I just showed in batch mode as opposed to interactive mode, I must first prepare a script which will be submitted to the scheduling system. Here, I have prepared a simple script called hellohpc.sh. Once I submit the script, it will be executed on one node from the granted resource allocation, and then notice that within this script, I'm calling srun, which will launch my program in parallel using the full resource allocation which has been granted for this job. Notice the comments starting with sbatch at the top. This is another way of specifying the job option. It is more reproducible and is recommended as compared to specifying them directly in the command line. I can submit the script for execution using sbatch. When I now press enter, the job is submitted to the queue. I am now free to log out and go about my day and come back at a later point to examine the results. You can see that the job is currently pending in the queue. A short while later, it is now executing. The job is now done. I can examine the log file to see the results. As you can see, the message from the orchestration script is printed at the top. Next, after calling srun, the output from the individual ranks is recorded. Here I have 40 ranks running on 6 different nodes. This is conforming to the job parameters which I specified in the script. Specifically, the lowercase n option, which defines the number of tasks which are supposed to be run. Thanks for tuning in. We hope you found this tutorial useful.